Okay, so our next speaker is Niamh Cullen from the Dublin City University in Ireland, and her speech is about the potential response of various slopes to climate change. So the floor is yours.
Thank you. I'm just going to share my screen. Make it full screen. Okay, you can hear me?
Yes, perfectly.
Yeah, okay, perfect. Okay, thank you for having me today. I can't think of a better way to celebrate International Women's Day than to listen to all this amazing research. So thank you to the organisers and all the speakers. It's been really inspiring so far, so thank you. I'm Niamh Cullen. I'm based in the School of History and Geography at Dublin City University in Ireland. And today my presentation is it's kind of a more desktop-based study due to lack of opportunities to get out in the field. I'm a coastal geomorphologist, but this is more about inland slopes, although there is a little bit on coastal stuff as well. So I have a kind of broader interest in slope stability and climate change in general, as well as the coastal geomorphology. So just to give a little bit of context in terms of looking at the potential impacts of climate change on slope stability in Ireland. There has, of course, in the last decade or so, been a number of different studies done on looking at the impacts or the potential impacts of climate change on slope stability. So they've tended to be regionally specific studies, and they've benefited from records, documented events, climate models, and also weather data to do these studies. So the general consensus from all of the regional studies is kind of two main outcomes. Is that yes, theoretically there is likely to be an increase in the frequency of all types of mass movements due to climate change. But I suppose that the second one, and the one that kind of inspired me to do this research, is that really the kind of outcome, the need for regionally specific studies because of the different variables involved. So to do this in this study, which I did with Dr. Mary Burke of Trinity College in Dublin, the kind of, I suppose, on the format for the rest of this talk is what we first did is look at the landslide record from Ireland and compiled the database of landslide events, and then look at the different climate factors that influence slope stability. And we then looked at kind of the predictions or potential predicted climate changes for Ireland and how they were related to those climatic factors that influence slope stability. And then we looked in the literature to see where those climatic factors were cited as either causal or contributing factors to mass movements in the Irish landscape. And then at the end, I've just included a couple of kind of more quantitative analysis of some more recent landslides, looking at how those climate factors might have influenced those failures as well. So that's the kind of outline of the talk. So this is Ireland's landslide record. And basically what we did was looked at all of a number of different databases from the Irish Annals, which date back to sort of the 12th century. They're the written records dating back to the 12th century. We looked at Twitter, newspaper articles, online news articles, archaeological studies, and then of course the academic literature. So the Geological Survey of Ireland has a landslide database, which we also utilised as of 2018, which was, I think, the last time it was updated. There was 2,805 landslides in the database. We added another 30 odd landslides to that as of July 2021, that should read. And in that database then, the oldest landslide that we have, it dates back to the Holocene, 4,200 years, calibrated years before present, and that was actually recorded in an archaeological study of a human settlement where they found evidence for mass movement. The first recorded one comes from the Annals of the Four Masters, that's those written records, and it was recorded to happen in 1488. That's the oldest written record that we have of a landslide in Ireland. The latest one, I haven't heard of any this year, but the latest one then towards the end of 2021 occurred in New Ross in Wexford, and that's associated with some human activity, which I'll be talking about a little bit later. So this is what the database looks like visually as we move through from the Holocene up into the 2000s. We've done it by century. You can see the number of recorded landslides on the y-axis there. There's 268 events in that database that have known event dates, or where we can roughly say when they occurred. And what you can see is that there's a significant increase from the sort of 1900s up into the 2000s. So again, I'm not saying that that's obviously, we can't say definitively whether that is the impact of climate change. More likely that's an artifact due to, you know, an increase in written records, you know, more people recording or more observations of landslides, rather than it being an artifact of climate change itself. In terms of the kind of materials that the landslides have occurred in, so in that database, there's about 955 landslides where we know the material type that the failures occurred in. You can see from the figure there that the majority, around 45% of the slope failures recorded actually occur in peat, which is perhaps unsurprising given that there's almost 20% of the Irish landscape that's actually covered in peat that formed during the Holocene. Again, I think there may be a sort of artifact of the record in here. So for example, rock failures or earth, which would be the quaternary unconsolidated quaternary sediments. Most of our coastline is quaternary unconsolidated sediments and rock coast. So, you know, there's not an awful lot of records of the kind of coastal slope failure. So again, it's likely that there are more rock and quaternary slope failures than are recorded in the database, but just that they haven't been actually observed or recorded or in the record. But the majority, again, occur in peat. So what you will see is actually quite a lot of the publications and the work that has been done are on peat failures in Ireland. So that's a kind of summary of the landslide record. And now just going to look at some of the climate factors that influence slope stability, and then look at the climate factors or the climate predictions for Ireland. These 6 factors, climate factors that influence slope stability, are based on Michael Crozier's work back in 2010. The first are weather antecedent conditions. So this is related to the amount of water held in the material prior to the event. Higher rainfall intensity, so we get intense rainfall and the soil becomes saturated and maybe the infiltration capacity is exceeded, and you get increased pore water pressures or formation of perched water tables and slope failure. Hotter and drier summers, so this tends to be related to, you know, cracking or soil piping or in materials. Antecedent dry conditions then followed by intense rain, so you know you might get hard packing of the surface, or the cracking that allows the water to infiltrate down into impermeable surface quicker, and then the infiltration capacity is exceeded again, which might influence slope failure. And then the final 2 then are kind of more related really to coastal slope failure, so the increased wind speed and duration, although it might be related to tree relevering at the coast, it's more related to the, you know, increase in significant wave height. And then a shift in cyclone tracks and other rain-bearing weather systems, and obviously all the factors that relate to, you know, rainfall and rainfall intensity and wet antecedent conditions that brings. So they are the factors that influence slope stability, and these are the climate predictions for Ireland. If my screen will move on to the next slide, there it is. The first climate prediction for Ireland is that we will see an increase in winter precipitation receipts, average winter precipitation receipts overall. The second one is for an increase in winter precipitation intensity. Okay, so, you know, more intense rainfall events, and it's predicted that these kind of intense rainfall events are also going to increase in frequency. The third climate prediction for Ireland is that summer precipitation receipts are expected to decrease while temperature increases. And obviously, if you've got warmer air, these drier summers are going to be interrupted by more intense rainfall events. The final two then again are related to the kind of coastal, the overall increase in energy content of wind for winter months, and then the North Atlantic storm tract is expected to actually respond to changes in climate by strengthening and tracking further eastward. Okay, so it's pretty much one for one, those climate factors that influence the stability. Each and every one are actually a climate prediction for Ireland in the future. So what we did then was to go and look at each one of those climatic factors that influence slope stability and look in the literature and see where these had been cited as causal or contributory factors to slope instability. So I've only included a couple of examples here. In 1996, the bog flow at Knocknageeha, it was a very wet autumn followed by not quite intense rainfall event. Bog flows in Northern Ireland, again, the same wet antecedent conditions. The same occurred at Straduff in County Sligo in 1984, and then at Mean Bog in Donegal in 2020. So that's a kind of more recent rainfall event or slope failure event where weather antecedent conditions are thought to be contributing factors. So if I just look at what we did for the more recent event was look at the long-term average monthly rainfall receipts in the months leading up to the event. So on the y-axis there, you can see the deviation from the average monthly rainfall. So the weather station was located about 5 kilometers from the site itself. It was the closest one. And what you can see actually is that in the 3 months, so anything above the line in blue is obviously above average monthly precipitation, and anything in red below the line is below average monthly precipitation, with the average percentages or percentage deviation from that mean line. So what you can see is in the 3 months prior to the event month that there was actually above average rainfall, which probably led to waterlogging of the soil and infiltration capacity being exceeded. If we look at the weeks and the days leading up to the event itself, and what you can see is in the sort of 2 weeks, you've got above average monthly rainfall, but at the event rainfall itself was not very significant. So it's only about 4 centimeters on the day itself that the peat bog failed. So again, it's, indicative of, those antecedent rainfall conditions being quite important in terms of contributing factors to slope failure. So the second one then was higher rainfall intensities. And the second contributing factor, again, this is cited as a causal factor or contributing factor for a number of different slope failures across the Irish landscape at Quillick Mountain in Northern Ireland, Croagmoyle Mountain in County Mayo. This higher rainfall intensity at Croagmoyle was thought to have formed a perch water table. So that's the image on the right hand side. You can see that's actually a peat slope, but it's underlain by kind of less permeable liassic clays. So it was thought that that intense rainfall led to the formation of a perched water table and then increased pore water pressures and then slope failure. One of the things to note is that there's quite significant variability in rainfall intensity, small scale variability. So you can't see the slope on the left, but the slope on the left, there's no slope failures at all, so there's seems to be quite random in terms of, or it appears to be quite random sometimes in terms of where those slope failures occur, and that's mainly due to, that small scale variability in rainfall intensity. The third and fourth, and then they're kind of related, so I've bunched them together again. Those hotter, drier summers, leading to one of the kind of predictions for how this might impact slope stability is that in that accelerated buildup of methane and then the kind of buildup of the gas and explosion of the peat mass. Some of the alternative views on this are that actually, those hotter, drier summers might lead to increased potential evapotranspiration, kind of, to offset that increased or that rainfall. And then the fourth one, then antecedent dry conditions followed by rain. So the effects of this wetting and drying cycles causing increased fissuring in the peats or widening of joint fissures in rock. And again, there are a number of different publications in the literature for Ireland where both of these kind of climatic slope influence factors are cited as causes. And the most recent of those would be the Dawn of Hope, which is Shass Mountain. This is a County Leitrim, just up in the northwest of Ireland. So we did the same kind of analysis for this as we did for the previous one. This is just a couple of images. You can see it's quite a large peat failure covered lots of roads, destroyed the rivers. There was quite a significant amount of damage done after this peat failure. And then if we look at the antecedent rainfall conditions for this one, again, it's the same deviation from the long-term monthly average. And what you can see is that in the months leading up to the Dawn of Hope failure, that you've got significantly lower antecedent rainfall. So, well over 50% less than the average rainfall in the event in the months leading up to the event month itself. Again, we looked at the kind of weeks and days leading up to the event. So you've got those dry antecedent conditions. You can see that dashed line there represents the mean monthly rainfall for the 30-year records. What you can see, it's been quite dry in the months leading up, in the days and the weeks, but in the day, a couple of days before, and then on the day itself, what you have is a quite intense rainfall again. So again, more evidence for that, those dry antecedent conditions followed by intense rainfall as cited as a causal or contributing factor to slope failure. I'm just going to move away from the inland stuff now and have a quick look at the effects of climate change on slope stability along Irish coast. So this is kind of more what I've been doing, the coastal geomorphology aspect of things. It's a little bit more complicated, obviously, at the coast, because not only do you have those subaerial processes, but you also have those whole suite of marine processes influencing slope stability. So again, there's been a number of events, slope failures in coastal areas where they've cited subaerial processes, so freeze thaw, heavy rainfall, and again, heavy rainfall as contributing factors for those slope failures. And then on the other side, you've got other authors suggesting that, the marine or the wave action was a more contributing factor to the slope failure event. And then, so the problem with this is, I'm just going to back to this, is again, we don't have a lot of data for these coastal slope failures. So they're not generally located close to populations, or, they're not often observed, or they're not recorded because they've happened on the coast and there wasn't anybody there when it happened. And the evidence, of course, is washed away. So unless someone sees it happens or it directly impacts a coastal community or the coastal infrastructure, then we don't know that they've happened. So there's a lot of work to be done in terms of, documenting the slope failures along the coast in Ireland. So that's kind of mainly what those last two factors are related to in terms of their impact on coastal slope failure, that increased wind speed, duration, and the impact that it has on kind of significant wave height. And then also that shift in cyclone tracks and the storms that brings to the coastal environment, particularly for Ireland over on the Atlantic coast. So in summary, and just to kind of briefly summarize things, so these are the 6 factors that influence slope stability, and almost one for one, these are factors that are climate predictions for Ireland. And out of the 6, 4 of them are definitely documented as being contributory or causal to slope failures in Ireland in the past. So theoretically, yes, likely to see an increase in these kind of slope failures in the future due to climate change if those predictions come true. But again, as I said, there's a lot still that we don't know, particularly in terms of the coastal stuff. So where we want to go now is kind of start looking at maybe taking a geomorphic inventory of the location and styles of coastal mass movements, not just for the South Coast. There has been some work done on the South Coast, but I think particularly, and that's the area that I'm interested in, is, kind of rock slope failures and kind of documenting them and, building up the same kind of inventory that we have for the inland landslides. In terms of how we might, look at how climate change is actually impacting on our coast, we really need kind of, what we're really missing is that baseline data in order to see or monitor that change, So there's a real need to kind of, get a coastal wide monitoring system in place so that we can monitor any changes. Another element that would be really interesting doing is, we have a lot of rainfall data for Ireland, and we have that landslide database with those known event dates. So, there's a real possibility for that retrospective analysis of specific reef mass movements in Ireland where the appropriate resolution rainfall records exist, similar to what we've done with the Mean Bog and the Shas Mountain failure, where we looked at the rainfall, we build a bigger database and, do some more kind of statistical analysis of the data. Empirical downscale modelling is something that has been done in other areas. It is complex and it is site specific, and there's a lot more needed to be done, but I think before we get to that stage, particularly for Ireland. And then the final one, I suppose, is something that I haven't even touched on, because I think it's a whole other area, is the anthropogenic impact, not just in terms of climate change, but human activities on slope stabilities in Ireland. So a number of the more recent or high profile slope failures in Ireland were actually associated with construction of wind farms. So I'm not blaming the wind farms, but they were associated with constructions of wind farms. So that's a whole other area that we really need to start looking into, because we're really quite behind in terms of moving forward, and how we have the information that we give to stakeholders and planners and policymakers in terms of how we manage these slope systems going forward. So that's me, and thank you very much, and I'll welcome any questions that you might have.
Very much for a very interesting presentation.
Thank you.
I think we have time for one or two brief questions. If there is something, you can write in the chat, or you can unmute yourselves and speak up.
I can stop sharing, actually.
I would like to ask something. I was curious. I'm not sure if you said it and I missed it, but yeah, in the database that you collected, do you only have the landslides that occurred in the inland, or do you also have landslides from the coastal areas?
Yeah, there are a number. There are a few documented landslides for coastal areas. So I think there's about maybe between 5 and 10% of those in the database are coastal slope failures. It's really hard to go back retrospectively and look at coastal slope failures, because the coast is eroding constantly, particularly for the rock coast. Like the rate of weathering is so fast, 5 or 10 years, you can't even see if a rock slope has failed or not, so it's really difficult to document them, which is why I think we need ongoing monitoring of the coast to really kind of, much higher temporal resolution to, really keep an eye on that.
Thank you.
Thank you.